Question 11. The electric field around a positive point charge is shown. The particle or a particle with a negative charge is placed in this electric field, and the student makes the following statements. The electric field around the point charge is uniform. No, it's not a uniform electric field because it's a radial electric field. The further you go out, you can see that the field lines are getting further apart. So it's not a uniform electric field. So we can say that one is false. We'll put across it that one. The electric field exerts a force on the particle, and we know it's going to be a negative charge placed in the electric field. So we place a negative charge in this electric field, it will be attracted towards that. In other words, it will go in the opposite direction of the arrows of the electric field. It will be, in fact, will have a force exerted on it in that direction. So we can say the electric field exerts a force on the charged particle, and we can say that one is correct. Statement number 3, the particle moves towards the point charge. Well, that's true, because if it's a negative charge here, it's going to move towards the point charge. It's going to move towards that direction there. So we can say that that third statement is true. What we got, we've only got 2 and 3. We'll look down the list and we can see 2 and 3 only. The answer to that is D. Question 12. A physicist determines the mass of two subatomic particles X and Y. Subatomic particle X has a mass of 2.18 times 10 to minus 25, and subatomic particle Y has a mass of 1.68 times 10 to minus 27 kilograms. And the mass of subatomic particle X is, and we're asked to give the order of magnitude. Well, to compare the order of magnitudes, we just look at the two ones here. We do X divided by Y, and it's going to be 2.18 for the first particle times 10 to the power minus 25, and we divide that by 1.68 times 10 to the minus 27. Now, for orders of magnitude, we can ignore these figures here because they're roughly the same as Americans say in the ballpark. So we're left with the ratio of the following: X over Y is 10 to the minus 25 divided by 10 to the minus 27. And if you've got a negative power at the top, you just bring it up to the top line, you change its sign. So 10 to the minus 25, and it's going to be multiplied by 10 to the power 27. That's going to give us a value of 10 to the power 2, which is going to be 100 times, or another way of saying that is 2 orders of magnitude. So we say particle X is 2 orders of magnitude bigger than particle Y. Let's go down the list. It's not 130, not 130, not 100. 2 orders of magnitude less, no, and 2 orders of magnitude greater. So the answer is going to be E for that one there. You may have looked at it and said 100 orders of magnitude, but we're not talking about it. When we do that calculation, it's 100 times. But we compare the powers, that's when we talk about magnitudes. And of course, this one here is 2 orders of magnitude bigger than Y. So the answer is going to be E. Next two questions is basically your physics knowledge. Question 13, it says the force mediating particle associated with the electromagnetic force is, of course, the photon. So the answer for that one there, number 13, is E. If we come down the page to question 14, it says the following statement represents a nuclear reaction. And the reaction is an example of, well, we can see you've got 2 smaller nuclei here, and the 2 smaller nuclei come in to give you a bigger nuclei. So this is a case of fusion happening here. It's nuclear fusion, and if we look down the list, we're going to get an answer of C for that. So just 2 questions based on your basic physics knowledge. Question 15. We have to be careful of this. Light from a point source is incident on a surface. At a distance of 0.3 ohms from the light source, the irradiance on the surface is 4.8 watts per metre squared. The light source is now moved a further 0.9 metres from the surface, and it's this point here that you have to really watch. It's actually moved a distance of 0.9 metres further from what the original distance was. So in fact, the new distance is 0.3 plus 0.9. So now we go and do our equation work. We know that we've got the following. We've got I1, we can always remember this formula, I1 d1 squared should equal to I2 d2 squared. And we know the first irradiance is going to be 4.8, so we can easily work that out, 4.8. And the first distance is 0.3, so it's times 0.3, and don't forget to square it. But it's the other one you have to watch out for. We're looking for the second irradiance, but the new distance is going to be not 0.9 but 1.2, because you've moved 0.9 metres further from the 0.3 metre mark. So it's going to be 1.2 all squared. So that's the only trick in that question you have to be very careful of. So therefore that gives us the new irradiance which we're looking for. I2 is equal to the left hand side 4.8 times 0.3 all squared, and we're going to divide that by 1.2 squared. And if we do that with a calculator, we get an answer of 0.3 watts per metre squared. 0.3 watts per metre squared is the new irradiance, and the answer to that one has got to be answer A.